Physics Part 80. There are a few section questions here. Number 1, the lights in a school laboratory have a total power of 600 watt and are left on for 7.0 hours each day. In order to reduce fuel bills, it is decided to have the lights switched on only when there are people in the laboratory. This amounts to a total time of 4.5 hours per day. Assuming that the laboratory is used for 200 days each year, calculate the saving if 1 kilowatt per hour of energy costs 7.0 cents. 2. A car traveling at speed v along a horizontal road moves against a resistance force F given by the equation. F is equal to 400 plus kV square, where F is in newtons and V in meter per second and K is a constant. At speed v 15 meter per second, the resistive force of F is 1100 Newton. A, calculate for this car. 1. The power necessary to maintain the speed of 15 meter per second. 2. The total resistive force at a speed of 30 meter per second. Number 3. The power required to maintain the speed of 30 meter per second. B. Determine the energy expanded traveling 1.2 kilometer at a constant speed, 15 meter per second, 30 meter per second. Using your answers to B, suggest why during a fuel shortage the maximum permitted speed of the cars may be reduced. Moment of force. At the end of section, you should be able to define and apply the moment of a force. Should be able to show an understanding that a couple is a pair of forces which tends to produce rotation only. Define and apply the torque of a couple. Show an understanding that when there is no resultant force and no resultant torque, a system is in equilibrium. Apply the principle of moments. Show an understanding that the weight of the body may be taken as acting at a single point known as its center of gravity. When a force acts as an object, when the force acts on an object, the force may cause the object to move in a straight line. It could also cause the object to spin, rotate. Think about a meter rule held in the hand and at one, and so that the rule is horizontal. If a weight is hung from the ruler, we can feel a turning effect on the ruler. The turning effect increases if the weight is increased or it is moved further from the hand. It is moved further from the hand along the ruler. The turning effect acts at the hand where the meter rule is pivoted. Keeping the weight and its distance along the rule constant, the turning effect can be changed by holding the ruler at an angle to the horizontal. The turning effect becomes smaller as the rule approaches the vertical position. The turning effect of a force is called moment of the force. The moment of a force depends on the magnitude of the force and also on the distance of the force from the pivot or fulcrum. I beg your pardon, I can read it again. From the pivot or a fulcrum. This distance must be defined precisely in the simple experiment above. We saw that the moment of the force depended on the angle of the ruler to the horizontal. Varying this angle meant that the line of the action of the force from the pivot varied. The distance required when finding the moment of the force is the perpendicular distance of D of the line of the action force from the pivot. The moment of the force is defined as the product of the force and the perpendicular distance of the line of action of the force from the pivot. Referring to the figure, the force has a magnitude of F and acts at a point distance L from the pivot, then when the ruler is at an angle of theta to the horizontal, moment of force is equal to F into D is equal to F into 1 cos theta. Since force is measured in newtons and distance is measured in meters, the unit of the moment of force is Newton per meter, Nm.